One of the most fascinating kinds of binary stars is known as a spider pulsar. This is where you've got a pulsar, which is a neutron star, the remnant of a dead star, that is orbiting around a main sequence star. And it is orbiting so close to the main sequence star that it is blasting it with its radiation, evaporating it away. And so it's sort of thought that this is like the equivalent of like a black widow that consumes its mate. And there's a bunch of these out there, and they've been seen, and they're fascinating astronomically. But what if they were some kind of evidence of an advanced civilization that is using one of the most efficient methods of harnessing energy and using it for their purpose, maybe even to move the star around in the Milky Way? My guest today is Dr. Clément Vidal. He is a researcher at the Free University of Brussels. He was a visiting researcher at the Berkeley SETI Research Center. He has a new paper that proposes how an advanced civilization might be using this for their own purposes. We have a fun conversation about this, and then we also talk about some of Clément's other papers, for example, about how advanced civilizations could be using pulsars as a galactic global positioning system, as well as ways that advanced civilizations could be using X-ray lasers to communicate with one another, and how we could potentially eavesdrop on this. So enjoy this interesting conversation with Dr. Clément Vidal. Clément, what is a stellivore?
A stellivore, from the Latin, it comes from the Latin stella, which means star, and vorus, which means eater. So etymologically, it means a star eater.
That's awesome.
And so you can see it as a kind of type 2 civilization on the Kardashev scale, as a kind of variation on the Dyson sphere idea. So instead of having a whole sphere covering a star to capture all of its energy, the idea is that the advanced civilization would accrete energy from the star, would use the accretion. And it's actually an even more powerful way to extract energy in our universe than nuclear fusion, up to 50 times more efficient than nuclear fusion in the case of black holes. So it's just the raw energy is even better than nuclear fusion.
So, I mean, people are familiar with the idea of a Dyson sphere, of course. You are just capturing all of the illumination that's coming off of your star for some purpose. How would this stellivore concept be different from a Dyson sphere? Are you like actually siphoning material off of the star?
Yes. So that's the idea, that the compact object, which in accreting systems can be either a white dwarf, a neutron star, or a black hole, the compact object, by its gravitational pull, and also sometimes via magnetic fields or other processes, accretes matter from the companion star. And that's how the companion star can give some of its plasma to the dense object.
Right. So I mean, we see these out there, these companions where you've got some main sequence star that has a compact object orbiting around it, a white dwarf, a neutron star, a black hole, and it is siphoning material away. But you are, in this case, you're not going to stop what the white dwarf does what it wants, right? And so it's taking the material and adding it to its own surface, and that's how you get novae or even supernovae. How would an advanced civilization interrupt this process and put this to their own use?
Yes. So the thing that got me the stellivore idea was looking at these accreting binaries in a kind of biological way. So if you think about biology very generally, all living systems, they need to take in energy from their environment. They process it, they use it to survive, to reproduce, to grow, etc., for maintenance. And they also reject waste products or entropy. And so if you look at a low mass X-ray binary that accretes, the energy source is the companion star. the living thing would actually be the white dwarf, neutron star, or black hole, or just something around. And then these systems also, in the case of white dwarf, as you said, at least the cataclysmic variables, they have novas, and so it's not a total destruction of the system. It's matter that is expelled out of the system, and so I interpret this as being actually waste production, that they get rid of some waste. And there are some indications that it could be the case because at least in some white dwarfs, the elements that are ejected are heavier than the matter that has just been accreted. So that's not obvious because the thermonuclear reactions wouldn't be enough to produce these heavier elements. So it seems that there could be some kind of processing. Now the astrophysicists did develop some explanations by saying that the accreted material is actually mixed within the white dwarf, and then the heavier elements are expelled. But my interpretation is that it's actually waste products from the super civilization that are ejected.
Right. But I mean, this always comes back to that, if you have a couple of potential explanations for some kind of astronomical event that you see, as soon as you sort of say, well, aliens could be doing this, the aliens could be doing anything, right? And
right.
if the thing that you're saying is the aliens could be engineering the surface of the white dwarf so that it is producing these kinds of reactions, that seems like a stretch to me.
Yes, of course. So the scientific challenge is to try to make predictions based on the model, on the idea that this is a living system, and that are different from the astrophysical prediction. It's not easy, of course, because also in a certain way, all living complex things, they have to comply with the laws of physics. We're not doing magic. We're just using energy in a very particular way. We are very far from thermodynamic equilibrium as living things. But still, we are bound to gravity. We have to comply with the laws of thermodynamics. So yes, the challenge is to find predictions, to imagine what this implies and how the predictions from astrophysics will differ from the astrobiological prediction or interpretation.
And so in your paper, one of the things that you propose is that this is a way that advanced civilizations might move stars. What would be the mechanism for that?
Okay, the mechanism would be to change the dynamic of the system. So, let me step back a little bit. So imagine you are a Stellivore, you're eating star for your life during millions, hundreds of millions of years. Inevitably, at a certain point, the star, your companion star, starts to shrink, start to have almost no mass anymore. And so if you don't do anything, it means that simply you will die, because there will be no energy to continue your activities. And so here the idea is that I started to look at the accreting systems that had a very low mass companion star to see where they would be going, to look actually at their proper motion in the Gaia catalog, to see if they would be going towards a nearby star. I discovered the hard way that astronomy is such a difficult science because, especially for the distance, the uncertainties are very big. And so at a certain point, I thought, okay, I will try to zoom in, and if these things are really moving intentionally, then there should be some way to control the system, to move the system in all possible directions. And that's where I got this idea of the spider stellar engine. So the mechanism, to answer your question, is if I can take this companion star and here you have the neutron star. So the weird thing about this idea is that it's different from any spacecraft we conceived, because there is this binary nature. There are always orbiting one another. So, for example, if you want to go to that direction, one idea would be to create a thrust by evaporating the companion star, some mass of the companion star, and because of Newton's third law, if this evaporated material reaches the escape velocity of the system, then there should be a thrust force that is created. The neat thing is that you can use it to not only accelerate, but if you want to decelerate, you would wait that your companion star is in front of you, and then you thrust the opposite direction, and it would slow you down. And you can also decide to evaporate at any orbital phase, and therefore go actually anywhere in the orbital plane.
Right. So in other words, you are timing the orbit of the white dwarf around the companion star so that it makes the closest point its aphelion.
No, it's not. It's not the orbit. It's the evaporation that you need to time. It's when you evaporate the star. So
is the mechanism then for evaporating the material from the star separate from the orbit of the? Because I was sort of imagining that you just brought the star close, and then that process causes material to evaporate off the star.
That doesn't work. The thing is that those systems have almost circular orbit. They are extremely circular. So there is not this dynamic. I mean, it could be possibly a way indeed, but it would be more complicated to get immediate control of where you want to go. Because it would work, but yeah.
I'm sort of imagining like one idea people have proposed that a way that you could move the Earth farther away from the sun is to do gravitational assists with asteroids. You every now and then drop an asteroid from the asteroid belt. It makes a close flyby of Earth. It does a gravitational assist. It steals it donates a tiny little bit of orbital momentum to the asteroid, raises the orbit of it steals a little bit of momentum from the asteroid, adds momentum to the Earth, raises the orbit of the Earth, and you're starting to change the actual orbit of the Earth. And as long as if the advanced civilizations are patient, they can be throwing planets close to, they can engineer three-body interactions to kind of get whatever they need done over long periods of time. But that was sort of my assumption going into it, but clearly not, that they're actually having some way that they're evaporating material off of the surface of the star in the direction that they want.
Yes, at the orbital phase that they want. So this is critical that because if you evaporate the whole time with the same force, then you have no net gain. It's like a drifting car in a circle. It doesn't go anywhere. So the evaporation, typically, if you want to keep a consistent direction, needs to be once per orbit at most.
And like, how do you envision they would actually do this evaporation?
There are two mechanisms, but mostly it's the very strong pulsar wind that blasts an enormous amount of energy, especially in the X-ray and gamma rays, and that's how the astrophysicists also explain why the companion star that is very much heated on the side of the pulsar and much cooler on the other side. So that's really the telltale of the spider pulsar category, is that you have this huge temperature difference. So it means that the pulsar wind hits the one side of the companion star. And yes, so the big question, I guess, is whether this this pulsar wind is controlled. If my hypothesis is true, then it should be controlled. If I'm wrong, then it should be just a continuous.
And I mean, these spider pulsars, I've reported on many of them in the past. Like, these are a real thing, that there are main sequence stars that have a pulsar orbiting around them very closely, and they're called spider pulsars because it's like a black widow. Like, this thing is destroying the companion star with that really intense pulsar wind. You get a pulsar too close to a star, and the star is getting eroded by the wind from the pulsar. And so in addition, there is a thrust potentially that could be produced in one direction if the timing works out right.
Exactly.
So, I mean, I think my audience is pretty familiar with other mega projects, and like one of the most common ideas is like a stellar engine or a Shkadov thruster. This idea that you build some kind of mega structure that you are pulling with gravity on the star. The star is pumping out radiation that is bouncing off of this megastructure, and it causes this constant thrust in whatever direction the civilization wants. That essentially the star's light is dragging itself around like a tugboat. How would the efficiency of using a pulsar compare to, the boring traditional stellar engine?
Well, in my paper, I have a table where I compare some previous stellar engine designs. So basically, the acceleration capacity of the Shkadov thruster is about 10 to the power minus 12 meters per second, minus 2. Well, yeah. Whereas the so-called active engines, especially the ones by Kaplan and Zvoronov, are more are between 10 to the power minus 9 and 10 to the power minus 6, really, if you push all the parameters right. So in the literature, there is often this distinction between passive stellar engines, such as the Shkadov thruster, where it's just radiation that is bounced back to create thrust. But there are at least, there are three other models. I mean, there is not a lot of literature on these ideas that propose to build an active stellar engine. And by that, it's meant that the star itself is used much more actively through a process of accretion and thrust. Accreting and getting and creating thrust with the matter that is collected. But in a way, the spider stellar engine is even more direct, because you just create thrust directly by evaporating, whereas the stellar engine of Kaplan and Zvoronov, there is an intermediary that takes energy from the star and that uses energy to afterwards create the thrust.
Right. And I think, there's going to be a segment of the audience right now that is listening to this, and they're saying, that's ridiculous, right? Like, come on. Who could imagine that advanced civilizations are going to be controlling pulsars, blah, 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 blah. This is nonsense. And like, fine, sure. But the point here, I think the larger point is that people are attempting to be creative about the kinds of technosignatures that we might be able to look for to ask this most fundamental philosophical question that we face, which is, are we alone in the universe? And so I want to chat about sort of just the larger idea of searching for technosignatures as a method of searching for life in the universe. Do you find that you're drawn to the idea of technosignatures versus, traditional biosignatures?
Yes. I've always been much more interested in searching for technosignatures because, well, for a variety of reasons, and the central one actually is about trying to demote humanity, in the sense that if we would find primitive life forms in the solar system or a primitive biosphere in an exoplanet, we would still be able to claim, yeah, there are other aliens, but we are the most intelligent. We have the most complex thing in the universe. And whereas if we would find a technosignature, something that is very advanced that does, then it would be a much, much bigger impact for humanity, for the best or the worst. Yeah.
That's really interesting, that I think because there is nothing as advanced as us here on Earth, we have a hard time wrapping our minds around what it might be like to be in the presence of something that is more advanced. Dolphins, chimpanzees, ants, they have a certain awareness that there is this creature here on Earth that does things that they can't understand and goes about its day and has implications for them, often causing fear, right? And so we don't have that yet. I mean, who knows? Maybe we're going to make that with our artificial intelligence, and we will learn to respect what it's like to be around something that's more intelligent than you. But if we did see that out in the universe and be like, wow, yeah, absolutely, that civilization is moving those stars around. They've surrounded those 15 stars in Dyson swarms. What is that? What do you think are the kind of philosophical implications for humans? What do you think we would do?
Yes. So in my book, I actually distinguished the impact of finding a biosignature or a technosignature, and so finding a biosignature would end the idea of biocentrism, that life only exists on planet Earth, and finding a trace of intelligence or technosignature would violate intellicentrism. I call it intellicentrism. So the idea that we are the most intelligent species in the universe. When I contemplated this idea of Stellivores at the very beginning, I got into a kind of depression, actually, because I implicitly had this worldview that we were the most advanced species in the universe, and that maybe if we are alone, or as long as we don't find anything else, we have a kind of duty or responsibility to maintain life and maybe spread it, to continue building complexity in the universe. But now I have a different view, and I think also from the Copernican principle, you can assume that generally, as if you would come to a city, you would find elderly people, you would find children, you would find adults, you would find people at all stages of their lives. And I think it's most likely the case with the galaxy. Maybe there are a lot of biospheres, a lot of primitive life, some complex life with multicellular organism or similar things, and also some super advanced life that can eat stars. And so it can be an ecosystem of civilizations or living things at all kind of different stages.
It's interesting that it makes like for me, the lack of evidence that we've found so far seems to tend towards us being rare or maybe even unique in the observable universe, just because if there are these advanced civilizations that have been moving their stars for billions of years, potentially before humanity got going, we right now, if you look in the Gaia data and you happen to notice one star that is moving in a trajectory that is interesting, that's you're catching them at the very beginning of laying ground on their interstellar highway system. But what does that look like 3 billion years after they've been at this? Shouldn't we see that out in the universe if this is the kind of capability that advanced civilizations will reach?
Yeah, well, I mean, I have a speculation that I haven't published, but
perfect.
So the
finally
idea is,
some scoops. Okay,
scoops. So as you know, there are the most common kind of stars are red dwarfs. that correct? Yes, red dwarfs.
Yes.
And
yeah.
so
red dwarfs. Yeah.
So the speculation is that maybe actually there are tons of Stellivores, and the red dwarfs are just the remains of stars that Stellivores have eaten, and they don't want them anymore. So it could be that we are actually super late, and they have already eaten a lot of stars.
Right. We showed up to the banquet late, and all that's left is the salad and bread.
Exactly.
All the good stuff is gone. Yeah, that's interesting. So there's another paper that you wrote that I thought was really interesting, and your proposal that pulsars would work as a galactic navigation system. So how would that work?
So it's kind of easy. It works almost exactly as the GPS system. So it's called a time of arrival navigation solution, where you have. So if we stick to GPS first, the GPS satellites they send two critical information: their timing, the time that it is for them, and their position in the sky. And by having at least 3 or 4 GPS satellites, the user is able to see the time difference between the signal that come and trilateralize its position and determine its position and velocity by doing it recursively. And the thing is that you can do exactly the same with millisecond pulsars, because millisecond pulsars rotate super fast, as you know, up to 700 times per second. And they are also extremely stable as the atomic clocks of the 1990s. And yes, I forgot to mention that indeed GPS satellites have atomic clocks on board of them, so that they can keep having a very reliable time signal. And so the amazing thing is that if you look at different millisecond pulsars, you can use them as the analog of GPS satellites, and the solution that you get, the navigation solution, is with about 100 meters accuracy.
That's crazy. Like that you can detect the signal from a bunch of pulsars and then know your position in the Milky Way to within 100 meters.
Yes, exactly.
Yeah, yeah. And this isn't theoretical. Like this has been tested. I know this has been tested on the International Space Station. Absolutely. That they were able to use pulsars to measure the speed and location of the space station to a level of accuracy that was, getting close to what they could do with the GPS system.
No, it was not as good. I think it was 3 or 4 kilometers
right
accuracy. But these are basically engineering challenges to get enough photons, and it's the first time that we determine a human object thanks to pulsar. So it's like the first experiment. But in principle, the theoretical limit is around 30 meters or 100 meters with some constraints of the interstellar medium.
Yeah, and so you could have a spacecraft that you put to sleep and have it go towards some distant object in the solar system, and then you have it wake up, and then the first thing it does is locates all the pulsars, figures out its location and velocity, and this could just be a standard piece of equipment that sits on every spacecraft.
Yes. And it's interesting you say that scenario, because one of the things that is remarkable with this navigation solution is that it can indeed restore its position after a reboot. So many navigation solutions, they need to keep track of the location to remain reliable. But in this case, you could shut down the whole system, wake up 200 years later, locate the pulsars, and get back your position.
Yeah, I mean, it's like this idea of dead reckoning. Like if you're on a sailing ship, that you measure how far you've gone, where you are based on how long you've been traveling and at what speed. But if someone takes your logbook, throws it over the side of the boat, then you no longer know how long you've been traveling and at what speed, and you don't know where you are anymore. But But a GPS, you just pull out your watch and go, no, here I am, right, each time. So, which is sort of the equivalent. So then let's scale this up then. So let's imagine, I mean, obviously advanced civilizations will be aware that these pulsars can serve this purpose. Could we envision that there would be something that they would be piggybacking on top of the pulsars as a way to make them maybe even more useful for a civilization that's trying to coordinate its actions across stars?
Yes. There have been a few proposals about this idea, and one that I have, which I think is extremely promising. Of course, it's my idea. In that. So these millisecond pulsars, you can use them as a kind of universal standard or galactic standard, let's say, for navigation and time. And so it means that in the search for interstellar signals, the messages might be compressed, encrypted, so very hard to decode. But there is one thing that generally is not encrypted, is the metadata. So here, the idea is that if we receive a narrowband signal or something that is normally a telltale of a technosignature, the first thing I would look at is whether there are coordinates encoded according to millisecond pulsars, because these are likely to be clear, to be ready to be read.
Right. So, I want to go back to this concept of technosignatures. And, I can sort of envision two types. One being the unintentional technosignature, and then the other being the intentional one. So in this case, the one where the civilization is just accidentally leaking some information about its presence in the universe, compared to one that is intentionally trying to look for. So when you think about all of the potential unintentional technosignatures, which ones do you find very compelling that we should ideally try to scan for?
I would follow the old idea of Freeman Dyson in his paper about the Dyson sphere, and just looking for, it might seem counterintuitive because it's more speculative, but looking for advanced civilizations that use a lot of energy, not because it's necessarily what you really believe is the most likely or most common, but just because it's the most observable. You have the most information. Whereas if you would search for super discipline regulated civilization that uses just a little bit of energy, yeah, there might be plenty of this too, but you're less likely to find evidence for them, given our observation capabilities.
And I like that. I mean, at the small scale, the type 2 civilizations, which have enclosed their star in some level of satellites, then that's going to be this really clear, bizarre infrared signal that we see halfway across the Milky Way. But that also scales up. So the civilization that has enclosed a large number of their stars in Dyson swarms in another galaxy, we see that as a peculiar object glowing in the infrared, yet with the structure of a galaxy. Like it stands out like a sore thumb, as they say. That's really interesting. So then what about on the intentional side? So let's imagine that a civilization is trying to let us know that they're out there. What do you think we should be looking for?
Yeah, that's harder to think about, because it would assume also that we are somehow special and worth contacting.
Well, I guess there's like, let anybody know, and then maybe let us specifically know, right? Like, how would a civilization, if they really wanted to broadcast their existence in their area, you know, what would be a way that they might want to do that?
Yeah, so I thought a little bit about that too, and so if you extrapolate future computing technologies, we are actually maybe just a few decades away from quantum computers, and so I think it's very likely that that interstellar signals are actually broadcasted as quantum, using the principle of quantum communication, because it would be more efficient. You would get more bits per energy unit, and also actually there is a kind of sweet spot, as Michael Hipke has argued, in the X-ray part of the spectrum that would maximize the bandwidth. Of course, the higher part of the electromagnetic spectrum that you use, the more information you can encode, because the wavelength gets more and more dense. But I don't think anybody has looked at doing SETI in X-rays, and neither in quantum communication. Some colleagues might be starting something soon, but I think this would make sense that communication is actually X-ray and quantum for interstellar communication. And of course, the big problem with this idea is that X-rays are filtered out by our atmosphere. So it means it's a project that needs space telescopes with X-ray telescopes. But we could still piggyback on the existing X-ray telescopes and try to look for anomalies or strange signals. And I think it has never been done.
No, I can't think of anything that's done. And people have obviously, there's tons of people thinking about radio. People have definitely started to search for optical transmissions, but I don't know of anybody who's searched for an X-ray transmission. And, once again, this idea of quantum communication, that has been tested here on Earth. I know the Chinese have launched a satellite that uses quantum communication, and the main thing is like error correction and encryption. But I can see in the case of civilization that is using this really packed X-ray laser to send a message, it's very easy to introduce errors. And so if you can somehow send along a signal that then with quantum computing, then you can make sure that you are receiving the signal as it was intended to be sent to you, and even know whether or not it's been intercepted, which I think is really interesting. So there's some interesting implications. Yeah, it feels like that there's going to be a most efficient way to send a tight beam signal to another civilization, and that some advanced civilization will have eventually stumbled upon that or capable of doing that.
Yes. Yes, and maybe the bad news for that, but that's for intentional communication, right? So the bad news for that is that this kind of communication needs to be extremely focused, extremely directed to maximize bandwidth. So it would be really a very targeted kind of communication. So this has to be an intentional communication. It couldn't be a leakage or very, very unlikely.
There was a paper that came out a couple of weeks ago that I thought was really interesting. People were saying that we could try to eavesdrop on the planets communicating within the TRAPPIST-1 system. That from our perspective, we will sometimes see transits where two planets are passing relatively in front of each other. And so if the planet that is closer into the star is communicating with the one that is farther away from the star, the size of the communication will go beyond the planet, and we may very well be able to pick up that transmission. And so you can imagine these situations where there are planets lined up and they think they're just talking to each other, but because the signal attenuates over time, then we might be able to get caught in the crossfire and eavesdrop on their communication.
Yes, that's a very cool idea. So it presupposes a multiplanetary species, which I think is reasonable.
Or you can scale that up to think about an interstellar species where, they've got two stars. We're lined up with those two stars, and maybe we can hear the signal as they're sending a message from one to the other, which I think would be really interesting.
Yes. There is a researcher, William Edmondson, who proposed something similar with pulsars, and he looked at the alignment of pulsars and exoplanets, and so basically said that the pulsars could be a guide or a way to relay information or to attract attention in these alignment situations. So he proposed to narrow down the targets of SETI to these exoplanets that are aligned with ourselves and other pulsars and exoplanets.
Yeah, absolutely. So, what is the Noosphere?
The Noosphere, it's the next major evolutionary transition, I would say. So it's a vision that has been proposed by Pierre Teilhard de Chardin and Vernadsky 100 years ago, actually. And it's about the only prediction you can find about the internet. So the idea of Teilhard de Chardin was that life on Earth with humans and technology is creating a kind of sphere of mind. Nous means mind, and sphere, and that would change radically the nature of life on planet Earth. That would gradually build up a super organism. So really something living at the scale of the planet. And I think that's, we are pretty much experiencing right now this situation where with globalization, we have had the trade routes that have been opened. The internet is the kind of nervous system for the whole. The GPS system is the timing part, because that's something we tend to not to notice, but actually the GPS system and global navigation satellite system in general, they provide timing information that is critical for coordinating all kinds of activities on Earth. So it's not only navigation, it's also just having the time very precisely anywhere on Earth. That's something that's also a big breakthrough of GPS. And yes, and also the value I see with the Noosphere idea is that it's a positive vision for the future of the planet. Generally, we focus, or we hear a lot about our demise, the fact that we are exhausting resources at an accelerating rate, and etc. But we are also building technology at an accelerating rate, and yes, innovation, intelligence is also growing. And so, yes, I think that in this vision there is hope that evolution is continuing and to a higher level that transcends human.
Mm-hmm, mm-hmm. And it's interesting. Like, I mean, as you say, these ideas are like 100 years old. Like that we had the geosphere, the geology, and then we ended up with the biosphere, the biology, and then the next step is this idea of just like the mind sphere, that more and more of the processes on planet Earth are driven by intelligence, as opposed to pure Darwinian evolution or just pure geological process chemistry, and that more and more of the cosmos will eventually, we hope, if we don't mess this up, will be influenced by minds. Which is very interesting. I hope you enjoyed that conversation with Clément Vidal. Now, we had a deeper conversation about a topic that I'm very interested about, which is how did it become okay to search for aliens in the universe? That 30 years ago, there was no funding for SETI, and yet now NASA is actually starting to fund various programs and projects. There are conferences that are being held at NASA and other research institutions that the people who think about the potential of there being aliens out there can step out of the shadows and have these kinds of conversations. And what did it feel like to be part of of this kind of renaissance in SETI? So if you're interested, this sort of deeper conversation is over on our Patreon channel. Now, this is available completely for free. You don't have to subscribe and pay us any money. You just have to go and follow us on Patreon, and you'll have a link to that additional part of the interview. So definitely check that out. Clément, what are you obsessed with right now?
Yeah, well, I'm obsessed with further testing the Spider Stellar Engine ID. And yes, as I told you before, I've been very frustrated by the uncertainties of the distance. So, for example, in the potential capture scenario that I describe in my paper, you have the millisecond pulsar coming and a potential target or target star that the Stellivore would catch, but it could be that they are just on different planes. So that is just an optical illusion. We think that they might connect. So I'm trying to explore any method that would reduce the distance uncertainty.
So if there's any like Gaia wizards out there who would be able to analyze the data and the motions of some of these objects and are looking for a collaboration, you're open.
Yes, exactly. Or using other methods such as VLBI, very large base interferometry, or even direct observations, optical observations of the specific spider pulsar and target, because with radial velocity measurement, you could further constrain the distance.
So like identify them in the Gaia catalog and then do direct observations using, say, VLBI of those objects. Because I mean, what's great is the pulsar is the best tool available to measure the speed and motion of an object, right? It gives you that redshift precisely. And so you could, to the point that you could detect planets around the pulsar, right? It's amazing. And so with someone actually focusing one of these radio telescopes, you could maybe get really nice motions and figure out if these things are headed anywhere.
Yeah, exactly. Thank you for the suggestion. Please write to me if you are an astrophysicist.
I'm sure there's some radio astronomers listening right now, and I'm sure I look forward to the collaborative paper. Well, Clément, thank you so much for taking the time to chat with me today. Good luck with your research, and let me know if you do find aliens.
I will. Thank you so much.
Thank you.
That's great.
Now I'm going to give you some of my further thoughts, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, Spiderswap.io, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I'm always fascinated by these really out there ideas for how we might be able to detect the presence of advanced civilizations in the universe. And it's very much on this spectrum of this high risk, high reward, right? That, the chances that we are going to detect some advanced civilization that is building Dyson swarms or moving stars or having nuclear wars or using their warp drives to get across the galaxy, it is incredibly remote. And yet, if we did, and if the signal was unambiguous and we could be certain what it is that we are looking at, that if we received an actual message from an advanced civilization, then the repercussions for that would be enormous, that it would ripple through our entire society. It would tell us that we are not the apex species, that we are not alone in the universe, and it would be one of the most important things that we could think about as a civilization. And so it's worth setting aside a little bit of time, a little bit of money, a little bit of our research for these high risk, high reward kinds of activities. And I don't think any of this will actually get funded. I don't think anybody is going to be doing these kinds of surveys because they seem so ridiculous. And yet, wouldn't it be amazing if we found out about it? So, I entertain these ideas, and I think a lot of people are very dismissive, and they're like, why spend 1 second thinking about this kind of thing? And it's because we love to think about stuff, that we love to imagine, we love to speculate, we love to consider the implications of what we will become in the future as a civilization. And so it makes sense to wonder if we could see that out there in the cosmos. All right, we'll see you next time.